Howdy folks, welcome to my first live stream on a Friday. We're going to go ahead and try and do this about every other week or so and see how that goes for us. Today I'm going to focus a little bit on CAD, just some simple stuff. I'm going to spend about an hour showing some different tools that are available to us in Calypso as far as CAD models and such goes. So without further ado, let's go ahead and write a little program. So start a new program, and of course first thing we're going to do is save that program. We'll just call that CAD demo. Today's the 19th, 05/19/17, V1 for version 1. And I'll hit save. First thing I'm going to do is bring in a CAD model. So we'll go here to our training CD. And under CAD files, I'm just going to use the standard training block. This being an SAT file, we can of course just drag and drop that into Calypso. Go ahead and move that out of the way. And so there's our CAD model nicely brought into Calypso. First thing we're going to do, of course, is heal that CAD model. So we'll just go here, build geometry, click OK, and of course the CAD model itself is fully healed. Now, rather than starting to actually program on this CAD model, I do want to spend a little bit of time going over some of the tools that are available to us in Calypso to actually manipulate a CAD model. So with that said, let's go ahead and drop into the CAD pull-down menu. Of course, CAD Load is the command we just executed, and automatic healing is the first thing we're going to do. So let's take a moment to look at the healer settings. Right off the bat, you'll see that there are 4 checkboxes and some sort of a tolerance value. Quite simply said, all you ever have to do is click Build Geometry. It automatically checks these 2 previous checkboxes for you. It does make the tolerance available to you. The 000394 should be an obvious conversion from inch to metric, so there should be no surprises, as it were, on that number. Excuse me, there we are. And this is the type of number that we usually don't have to modify with modern CAD models. It is possible, if you're going from an old enough CAD model, that you might have to increase this number. How much do you increase it? Boy, that's a kind of a shot in the dark. I usually start by doubling the number and just go from there. I've really only had to adjust that number maybe on 2 models ever, maybe. So with that said, we can click OK. Now you can't overheal a CAD model anymore, so there's no danger in actually doing that process 2 times. Now sometimes you'll get a large CAD model in that really bogs down your system. I find these tend to be things like electric motors with lots of windings inside or what have you. So there is a process that actually reduces the resolution of the CAD model and makes it a little easier for Calypso to process. And to do that, you start off with the normal healing process, so CAD file, automatic healing. Then you're going to do only the simplification, so the first checkbox only. And we're going to click OK, and we're going to let that run. Then we're going to come down to the CAD pull-down menu, Modification, and under Modification you'll see that there are 3 additional commands available to us. Combine CAD features, delete free lines and points, merge faces with the same geometry. Doesn't really matter what each of them does individually, because we're going to always do all 3 of these commands simultaneously. So first we're going to combine CAD features, then we're going to come back, delete free lines and points, then we're going to come back in here again, and we're going to merge faces with the same geometry. There we go. Then we come back into the automatic healing, and we perform the full heal by clicking Build Geometry and click OK. That right there will greatly reduce the CAD model's sort of load on the system. Now, a couple things, and these are kind of minor details. If you find yourself slowing down or bogging down with your CAD model, make sure you do things like get rid of your desktop bitmap, minimize the number of icons that are sitting on your desktop, get rid of any arrow themes that you're using from Windows 7, 8, 9, or 10, depending on what you're running here. I guess there's no really 9 that anyone used, at least. So that's that. The other thing that leads to load on your system is the resolution of the CAD model itself. So if I zoom in far enough, you can see that the surfaces are actually tessellated. They have a polygonization to them. And there is actually a tessellation to the wireframe, but the wireframe tessellation is either different or a little bit finer than the tessellation is just creating these facets of the wireframe version of the model. Well, the way Calypso works, and this is actually just based on it having the ASYS CAD kernel, is wherever we're zoomed to when we do a quote redraw or refresh, that's the level that the refresh will happen at. So if we come here to our CAD settings, so CAD settings, and let's see, right here, I think under system, no, view, there it is. We have our display quality, and right now I'm currently have this set to medium, and of course you see that there is a high, a very high, a low, and a very low. So right off the bat, if you don't have a very powerful computer, make sure you've set yourself to a lower resolution. But that is also a kind of secondary to where we are zoomed at when we just go CAD, View, Redraw CAD Model. And so if you saw when I redrew the CAD model, the wireframe has now less tessellation. In fact, now it's tessellated to the zoom level that I was currently at. Now we still see some tessellation from the solid model, and that's the one if I wanted to fix. Again, I would just go to CAD, Settings, View, and in this case, go to a very high, and now you can see that the tessellation has been removed or reduced along this edge, and it pretty much matches the wireframe. And as we zoom out, that same fine resolution is maintained. That can be handy if you're trying to program a point, directly on the CAD model, and you want to get, very close to the edge and make sure, well, see, there you go. I went ahead and hit the wrong surface anyways. But we want to get very close to the edge and have it actually land on the right surface. Now, something a lot of people don't know is you can actually click near the edge like this and then just drag your point, and as soon as you kind of get to the edge, see how it stops? So we can just pull that right up to the edge if I needed to for any particular reason. Now, the point is still there. A little bit of a bug. Oh, maybe it's not. Oh my gosh, it snapped out into space. Don't know what's going on there. Must be another bug. Let's hit reset. There we go. Drag it to the edge, release. Hey, look at that, it's back in space. Well, maybe that doesn't work as well as we would like. What? It's back where it belongs. Calypso will make a liar of me every time. Let's bring that over here, right up to the edge. Looks good. Click OK, open it back up, and it seems to stay where we want it. And I push it right up to the edge. Yep. OK, reopen, and now it stays at the new location. So a little bit of a graphic bug, but it didn't seem to play out in what actually happened once we opened and closed the feature that we created, in that case a point. So that's a few things about just healing the CAD model and loading the CAD model. Now I want to talk a little bit about rotating and changing the orientation of the CAD model itself. So the most common tool we're going to use is right here under CAD Modification, CAD Model Transformation, and this is a very simple tool. Basically, if I want to move the model 1 inch in the x-axis, I can type 1 inch, hit apply, and you can see that relative to the CAD origin, and that's what this fat arrow is, by the way, that is the CAD origin, it has moved 1 inch. And if I want to move it back, I can easily move it back. Now, if I'm not sure how far to move the CAD model, I can use the define points function. Come over here and click. Now, it's important to notice right here that there is some kind of rounding that's going on with this nominal. So the actual location of that point is 7.480315. So I would actually want to use that number potentially. So I can just highlight that number, Control C for copy, or of course right click copy, close that point, and then I can paste that number here. and move my origin to the other corner if that's what I want to do. Okay, so, and we see, of course, I've just put everything back to the original location. We'll delete that dummy point. Let's go back into CAD, Modification, CAD Model Transformation. So that was a simple translation of the CAD model. Let's go ahead and do some rotation of the CAD model. Again, you see we pick which space axis or which axis we wish to rotate around. So right now it's set to Z. I can set 90. Now, of course, using the right-hand rule, if I'm rotating around 90, positive is going to be this counterclockwise direction. So let's go ahead and apply, and there we see that. Of course, if you guess the wrong direction, just hit apply a couple more times and you can get where you want. Okay? And we'll move it back to where it originally was. And of course, we can rotate it around any given axis, so rotating around X and rotating around Y. Pretty simple. In all cases, it is obeying the right-hand rule for positive rotation. That also applies for the invisible negative axes. Now, one thing we may have noticed here is that this surface at the end is not exactly where it's supposed to be. We can quickly come back to our training CD and let's open up the drawing. So CAD files and numbered training block, there it is. And of course we can see right here that from the origin point on C, the width of this part is supposed to be 7.5 inches. Go ahead and minimize that for now. If I come into this plane, just by highlighting it, I can see right here that the nominal is 7.480315. And of course, that's what we see when we open the plane as well. Now, from a measurement perspective, that's really no big deal. I can just type 7.5 and the plane here will exist where it's supposed to. So if I use it for flatness or distance or anything, I'll get the correct value. However, if I want to actually correct the CAD model, Calypso does have some tools that might help with that. So we can go in here to CAD, modify CAD entities. We have a couple extra tools inside of here. First off, we have this edit tool. So if I wanted to, for example, hide that sphere, I could do that, make all features visible again. Or if I wanted to change the color of one specific entity, maybe I want to make that sphere a nice blue color. Again, that's here. That blue color won't hold for very long, but it's there for now. We can go to the hierarchy. Under the hierarchy, we can see the various CAD entities that make up our CAD model. We can go to the transformation tool, which basically works just like the one we were looking at a second ago. So we can hit 90. Oh, sorry, in this one we actually have to select the whole CAD model. So I can go 90, and there you see me rotating the entire CAD model, and let's go back, minus 90, and we've moved it back. Interesting how that changed the color of everything except for the sphere when we did that. Next, we have this positioning tool, which is basically going to allow us to move the entire CAD model relative to a fixture or what have you. But we also have the possibility of moving just, one element. So this entire CAD model is a single piece, so we're only going to get it as a single piece. I can't really unselect it until I go to the hierarchy, and if we zip down the hierarchy real quick, oh, there it is. Now we see we have that entity selected, and I wonder if we can move it. Maybe, maybe not. And so as you see, we cannot move that one entity. Here, I'll use a big number. Obviously, we're not moving that entity around on its own. However, if we go into Create Geometry, it is possible for us to create a plane at the exact location that we want. So if we come here, X 7.5, And of course, that is going to have a X vector, something like that. And now from a size perspective, we could do this several ways. One, I can just kind of eyeball it by dragging these corner pieces in there. There's that one, and we'll bring this down right now. So there we are. We can just kind of eyeball things, or of course I can type in the exact numbers. So let's see, we'll bring our drawing back. Looks like our length across this side is 6 inches and our thickness is 1.5. So if we come over here and we'll put the center at 3 inches and minus 0.75, and then when we look at the expansion of the part, right, we can go with 6 inches and 1.5, and so now we mathematically have made this plane basically exactly correct, except for this end piece. There's nothing we can do about that small angle. But then I can hit create, and now you see we actually have a plane that exists exactly where I need it. So if I have to program a point or anything, that point is going to come out exactly nominal. And there's some tricky stuff we can do, so I'm going to just show you how we could still use the underlying plane to create a strategy. So we can go here, CAD, modify CAD entities. Now we're going to highlight our created plane. We're going to hide that feature. I'm going to go close. I'm now going to extract the original plane, open it up, strategy. We can see it already has a polyline. That's just from the default strategy that I've set up. I'm going to open up that polyline from model. Let's go with a 0.2 offset, polyline from model, 0.4 offset, polyline from model, 0.6 offset. Good enough. We've created this nice pattern right here. I'm going to click OK, and OK, and OK. Then we can come over here, CAD, modify CAD entities, all features visible, close, extract features. We now have this plane. I can come to the original plane that matches. It's selected back in there. There we go. Go back to the original plane. I can use the transfer format function to go ahead and transfer the measurement strategy from plane 1 to plane 2. Click OK. Let's go ahead and delete plane 1. We don't need it anymore. And now I have plane 2 clearly where it belongs in space, but its pattern matches the underlying shape as we found on the original plane 1. And let's get rid of that. And we'll go back into CAD, creating feature, modify CAD entities, and go to our hierarchy. That was interesting. I believe it deleted the plane that we created when I deleted the feature that I had extracted with it. Yep, sure enough. Well, that is very interesting. One of those weird side effects of Calypso, I'm going to do a CAD view redraw. Nope, and it definitely did not come back. Interesting. Okay, let's go back in and play with some more of the CAD tools. So here we are, modify CAD entities. One of the things that's worth looking at sometimes is the actual hierarchy itself. So right now we have this training block.sat. I'm going to go ahead and bring in a second CAD model. So we'll come here, training CD. We'll just keep this here so more visible. And again, we're going to go to CAD files. And let's just grab another control rod SAT, CAD Cube 2015 SAT. Interesting. Let's see what happens with this model. Looks good. So now we have our two components. And we could say that this bottom part is maybe a fixture and this top one is the part, and perhaps I have to mount the two of them together for one reason or another. So there's some tools in Calypso that make that fairly easy. So we can just go to CAD, modify CAD entities, positioning. Then I can grab this object. If I want to position it with one point, I can click here and I'm going to pick that point. I'm going to move that point to that point. Gives me a little preview of what it's going to do, and then I can hit apply to execute the change. Looks pretty good. Okay, and of course we can independently manipulate each of these CAD models. So I can grab this one here. Maybe I'm going to rotate it around Z by 90 degrees. Interesting, we saw that it did rotate relative to the CAD origin over here. So that's worth noting. Probably not unexpected. And of course, then that means I have to reposition it back on the surface. So let's just go and do that again. Oops. Position, click the start point, click the target point, looks good, apply. Okay. So there's also some other tools here. If I knew how far I wanted to move this, I could go ahead and say, click on this CAD entity, enter a value. Maybe I want to move this -1 inch in X. Looks pretty good. Now this manual move thing is always kind of interesting. You grab the object and let's see if I zoom just out far enough, maybe you can see that. There's this little sort of arrow that appears. There it is. And basically what you do is you grab that arrow and you can slide the part wherever you think you want to position it. So maybe I want to move it right up to that edge. And so that's my new proposed position. This will show me what distance I've dragged it to, and then we can hit apply. You'll notice that there is also a copy function. So for example, if again for whatever reason I'm going to take this CAD entity here and then I am going to simply I better move it at the same time. I'm going to move it in Z by 1.5 inches. And you'll see that I've created a second copy of the CAD model on top of the first one. I can take that second one, we'll go to transformation over here. Let's rotate that 180 degrees. So now I have the two parts sitting offset relative to each other, if that's what I desire to do. Or there's any number of things. It actually comes up a lot that people will ask me, how can they write a single program that checks an entire palette of parts? And of course my typical response is, well, you just go into Plan, Auto Run, and you do a palletized function. The problem with that is that if I have probe changes inside of my program, it can be very inefficient to run 4 different parts and then perhaps have 3 probe changes per part. Whereas it might be nice to pick up one stylus system, measure all of the parts for one with that one probe, and then pick up the second probe, measure all of the parts with the second probe, pick up the third probe, measure all the parts with the third probe. So using these CAD tools, we can simulate a palette of parts. Now it should be pretty obvious from the stuff I've covered, but just to make it clear, I'm going to go ahead and go through the steps right now. So here we go, CAD, modify CAD entities. First I'm going to get rid of some of this extra junk. Notice how every single CAD entity has its own thing here, so we'll just go get rid of that, and let's get rid of that. So now going to, excuse me, our original CAD model, we're going to go here. Now this time I know the spacing of my palette. So I know that my first position in Y is 10 inches away. So I'm just going to throw a copy 10 inches away. And I can just do that again and throw another copy 10 inches away. And heck, we'll even do that again and throw another one 10 inches away. And then in the other axis, let's say we have, oh, I don't know, 15 inches in X. Holding the control key on the keyboard so I can multi-select. And there you see I now have 8 copies of my part as a single CAD model. Now maybe I do want to represent the fixture plate that it's on and use that as a simple palette backdrop. So then we can go over here to create geometry. Let's change this from a 0 to a 1, and we will stretch that out just to kind of get a rough idea. Go. And let's see, of course in Z we want this at 0. Whoops, not normal vector 0. 1. Height of 0. There it is. And, oh, let's see. I'm going to say if this is about right there. So, again, I'm just trying to get myself a guess without having to actually do the math. So we'll go with 17. See how it looks? And then we'll make one of our lengths 34. So that's a little short right there. So let's make this 18. Yeah, that looks good. And then we'll make this 38. Again, I'm just guessing. If I knew the numbers, I would do them properly. And we'll put this at minus 1.5. So now it's sitting underneath our parts. And then in the other axis, again, let's see here. I'm going to say 12 is probably the right number. And 24. Not bad, not bad. So probably 11 and a half. Nope, straight 11. Yeah, somewhere between 11 and 11 and a half. Good enough. Okay, and again, we can expand this out a little bit. 26. Whoa, not 226, 26. So there we are. We have a nice little plane, and I'm going to create that geometry. Now, I'm going to do something a little bit tricky here, or at least attempt to do something a little bit tricky here. And I'm going to change the vector in X. And I'm going to move our center in X from 11.25 to, let's see, it's not 22.5. No, because I got to account for this extra amount. It is going to be, oh, math is escaping me. Math is hard. Interesting. Okay. But we seem to have unlocked. That's a good sign. Where were we? We still have this 11.25, so let's just change. I guess I'll change that to 13. Nope. 26. There we are. And again, if I was a little bit more prepared, I would have predefined the size of this based on some sort of a real plate that I really had. And so let's set ourselves to Z minus 1.5. And here. Something like that. And of course our height here, I think it should be this axis, will be, I think, 1. And we'll put this at -2. Okay, so that's looking pretty good. We'll create that. And then the last one. 0, change the vector into y. We're going to now move this plane to the front, create it over here. So again, just going to guess at the center. Try 0. And then -2. I think that was about right. Nope. -1. Close enough. And again, we're going to go with z -2. That stays the same. And over here, height of 1. And I'm just going to drag that rather than figuring it out. And create. So now I have used the quote create geometry tool to simulate a subplate, and I've used the copy and position command to simulate putting 8 versions of my part on this palette. And then of course if I wanted to program this as a single part, that's pretty straightforward. We'll just bang that out real quick. So let's see what I have. Looks like I have a 2mm star active. We'll go ahead and turn on the stylus system simulation. Show my machine. There we go. Now, of course, I probably want to mount that all on the table. A little bit of a challenge. Let's see. I think I need to create one more entity to make that easy on myself. And we'll just go to CAD, creating features. Excuse me, CAD, modify CAD entities, create geometry. We're going to now create a bottom plane so I can move all of this at once. So in this case, we have a normal vector of -1. So it's pointed straight down. And we could probably just grab these handles. There we are. And again, I'm just going to eyeball it. That's the bottom of the fixture, so it doesn't have to be too exact. Create. And whoops. Put that at the wrong place. I'll delete the wrong one. But we actually want to be not at -2, but at -2.5. And we'll create that there. Let me go to the hierarchy. Woo, look at all that stuff. And there's the one that needs to be removed. Okay, looking good. Now again, we'll go to CAD. Excuse me. We're going to go to the Stylus System Simulator. Stylus System Simulator. There we are. Let's show our CMM. There's our entire CMM. Of course, we have to mount the plate on the table. So here we have our positioning tool once again. And in this case, let me select all of the entities that we're concerned with. Let's see here. There we go. That's interesting. It doesn't seem to want to let me select that. That is an unfortunate challenge. What are we going to do about that? Let's see. Transformation. Let's stop the simulator. Go back into our CAD tools. modify CAD entities and see if we can do something about these. I can definitely select the plane there, and there I selected another one, and another one, and that one. So I've selected all of those. Okay, so far so good. And what can I do to those? Let's see, the hierarchy. Well, let me form a group of those entities. Show, delete, work area, edit. Nope, that's just renaming. Transformation. Well, it looks like I can at least move them, I guess. Maybe move it down in Z. Yeah, well, I can move those independent of the parts. But can I move them, or can I select them when I have the CAD simulation open? So let's give that a try again. So we'll go to CAD, Plan, Stylus System Simulation, and Positioning Tool. Does seem to let me select. Nope, that was that. So it just doesn't let me select those entities in this mode. What if I go to here? That might be the way to do it then. So let's just select everything. Nice. And I do need some kind of simulation of the table. There it is. And let's see if we can position this whole thing on the table. Position. Just not letting me do that. There it is. Okay, maybe. I get the feeling that it's about to put those directly onto the table, but we'll have a solution for that as well. Maybe. Let's see how that goes. Apply. That was less exciting than I would have hoped, to be honest. So let's see if I can figure out where that table is and move things manually. So we'll go define points. Well, let me put one there. That was interesting. So that point is currently at minus 23,622,047. So we'll copy that number, and then we will close the simulation. We're going to go to CAD, modify CAD entities, positioning. Let's just grab everything off the hierarchy first. Positioning, and we're just going to translate that whole thing, that value in Z. Very nice. From there, feeling pretty good about what's going on. So let's see how we look in the simulator. Planner, Stylus System Simulation. Obviously we need to move over in X and Y still. And go up, apparently. I'm going to say we need to go up 1.5, 2.5 inches. And I'm going to move us back in Y some 35 inches. So let's try that again. CAD, modify CAD entities. We're going to go ahead and go to the hierarchy, select everything, and then we're going to move this up in Z 1.5, 2.5 inches. That's the thickness of the part and the thickness of the fixture. And then we're going to move it in Y, again, minus 35 inches. That's knowing that the machine is 48 inches long. So that's just kind of a guess of a decent position on the machine somewhere. And then I'm just going to move it over in X by about 5 inches. And let's see what that looks like relative to our machine. Planner, stylus system simulation. There's the machine itself. And that's looking pretty good with our fixture basically sitting somewhere in the center of the CMM. I'm going to move this little window off to my other screen so we don't have to look at it. And let's see what we can do now. So again, we might want to create some sort of a base alignment that first measures and sets up the fixture on the machine itself. So we'll just take care of that. Yep. And we'll go in here, create a new base alignment using the standard method. And we're going to go to extract features. And we're first going to get our top plane that represents our palette. Now I'm just going to do a line down the side here that's going to represent my axis alignment. So let's see, I think I'll bring it this direction. Looks good. And then I'm going to define a point here on the front, and that'll be our fixture location, as it were. Click that as OK for a base alignment. Look at that. Look at that. Ugh. Tricked and stymied every time, huh? Oh well. We'll fix that in a minute. I know how to fix it. Just like that. See, it runs perfect. Anyways, let's go ahead and write our program. So we're going to do our clearance planes from CAD Model. Now the clearance planes, of course, have to accompany, clear the fixture and everything. 1 inch as a nice safe distance. Hey, that looks pretty good. I do, in fact, want it to encompass this other side, so we will take the plus X direction, and we'll set that just to a simple inch. That looks good. And in Y, let's go with minus an inch. That also looks good. So that's a pretty reasonable clearance planes, I think. Yeah, it's off the back of the part, too. Not bad. Click OK. And, of course, we don't need to update any clearance plane settings at this exact moment. And we'll just call this plane fixture top. Now it has a nice little path automatically. I'm going to open that up. And let's see, this path starts right there. Not bad. And let's go ahead and just create a new path. So polyline from model. This time I'm going to stay about a 1/4 inch away from the edge of the thing. So 200 thou. That should be good for our fixture. I'm going to go pretty fast. You know, I don't even think I need to scan that whole distance. That would be kind of ridiculous. So let's rethink that. Let's get rid of this polyline altogether. And instead, we're just going to take some single points. So let's just go in here and go 1, 2 points right there, 2 points there. On such a big fixture, I'm just going to take 2 points in each corner. The 2 points, in case 1 point hits a piece of dirt or a ding or something, the 2 points have a little less susceptibility to errors. So there we go. So we just got a nice couple points. Looks great. I probably want to put a clearance data in between each pair of points, just so we go up above the part. So that should be fine. And OK. On the 2D line, now that the probes goes 1, 2, 3, 4 to this corner, now it makes sense that we're coming back in this direction. Of course, zero-wise that. Let's see, we're going to start at 35. I'm going to go for a distance of 35. No, we're going to go for a distance of 30. That looks more like it. Strategy, line auto path. Let's just take single points, so 5 single points. That should be adequate. And height-wise, that looks pretty good. We'll set that at minus ½ an inch. And of course, we're going to call that 2D line fixture plus X. For the point, that's going to be point fixture minus Y. And as far as location goes, that looks pretty good. We'll go minus an inch. and minus ½ inch. Very reasonable. And let's click OK. So now we have our 3 elements that are going to make up the base alignment. Looks pretty good. I can always test run that now, so I'll hit save, run. Oh, here we go. Features list, clearance planes, normal mode. I'm in simulation, so I can leave the speed at full speed, custom printout, clear existing results. I can run a nice manual alignment, and we're going to check all characteristics. So of course, since I'm running the manual alignment, it's going to actually ask me to take some probings. And done. Okay, so it's a nice little setup there. Now, of course, now that we have a base alignment and all that, I bet I could try positioning it on the CMM. But doesn't matter, so let's write a quick program. Okay, so now we're going to actually set up to measure this part. So to do that, we of course need a sub-alignment, and this one we're going to call this alignment position 1. And we're just going to create a plane here. I'm going to measure a circle in that counter bore, and then I'm going to measure a line over here. Nice. Okay, so that's our base alignment. Very simple. I'm of course going to keep things grouped together. So this right here, form group, F2, and this is going to be the fixture group. And then we'll make a group out of these as well. And these are going to be the plane A, P1. And this will be circle D, P1, position 1, P1, 2D line B, P1, and we'll correct the angle here as well. So we have a nice, reasonable alignment, and of course we rename that the group P1. Nice. And then we have group P1, and everything in group P1 is used so far to create alignment P1. And then we're going to go ahead and measure some features. So let's go in here, and we won't do too many. We'll just define a circle on a cylinder. Let's go ahead and get this counter bore, and let's go ahead and just measure the overall length right there. Now, of course, I'm going to have to set this to be relative to alignment 1. And set that. I believe that should be set in 50. In fact, I'm just going to assume that it is, and we can check that on the drawing later. Looks good. Actually, I'm going to just put that at 0, right? Why not measure the overall length right in line with the alignment, and Z minus 0.5. So that looks pretty good. Should probably put this at interesting. So Z 1.3 is off of there. This is 1.5 thick, so Z of 1 inch is at minus 0.5 relative to the top surface. Looks good. And of course, we'll put that in there, and we'll put that in there, and this just becomes circle P1. And circle P1 uses alignment 1, of course. And this is point P1. It's already relative to alignment 1, and we'll just call that P1. We'll output the X value. And we'll just call that dim 001, and again, P1. Looks good. Come back here, and let's go to that one, and we're going to output our diameter. Last input. tea ready. Fine, organic, partially fermented black tea. Delicious. Very nice. That's been steeping for a while. It is super strong. And we'll just call this dim 002. And again, we'll just call this P1. Okay, so we have a couple dimensions there. So this is group P1. And let me rename that to now 2mm star group P1. And now let's say I need to do a probe change. So A for automatic. I'm going to go ahead and pick up, what's handy here? Mostly small styli. I'll just use the 0.8 star. Load that from the holder. Now I have that stylus active. And let's just say we're going to take a couple measurements with the 0.8. Define a circle on a cylinder. And again, we make that relative to alignment 1. Let me correct the nominal. And depth minus 2.5. Go here, pattern. Let's go with a polar pattern. And of course, this is relative to alignment 1. My angular pitch is 60. I have 6 numbers. Does that look correct? Oop, not quite. So let's see here. My center should be at 0 relative to alignment 1. Okay, that sounds more like it. And now I see everything where I want it. Click OK. And we'll just output the position of those. And the diameter. Now we'll call this dimension 4. And we'll call the diameter dimension 3. Looking good. Looking good. And OK. And let's make at least one other measurement with this stylus. Let's go ahead and measure this radius here, I think. And so we'll just go define a circle on a cylinder. Grab that corner radius. And of course, I'm just going to output it simply as a radius. So modify, size, radius, OK. And now I can simply check it off as a radius, and this will be dim 05 P1. Also relative to alignment 1. Alignment 1, okay, looking good. And this will also be a group. And F2 to rename. And we're going to call this the 0.8 mm star group P1. Okay. So all looking good. Got a nice little setup going on, as it were. Now there's a couple things we could probably do. For example, let me see exactly what the spacing is between these. So simple way to check is grab a simple distance, open that up, grab 2 space points, boom, boom, and it looks like our Y distance is going to be exactly 10 inches. Looks good. And our X distance, I think, is 20 if I remember correctly. No, it's 15 inches in X, 10 inches in Y, so that's all we need to know. We'll delete that little temporary tool and blow away these temporary points. Excellent. Okay, now we're going to go ahead and, let's rename each of these as well, sorry. So now this is going to be circle BC P1, and this one is going to be the R1.75 P1. Cool. Okay, so now what I do is I want both of these to be, quote, repeated and used for other stuff. So there's a couple ways we could attempt to do this. A very easy way would just be with copies. So for example, if I take and make a copy of each of these, Control C, and paste, Control V. So now you see I have groups P2 taking advantage of the automatic numbering and everything that Calypso will do. And we're going to have a little bit of a problem with the pattern, but that's the only place that we're going to have a problem. But I'll fix that in a minute. You'll see what that is. So now I can come to alignment 1, POS, Control C, Control V. Right? Pretty easy. And then I'm going to create a temporary alignment. Now this is where things get a little tricky. I'm going to take my 3 alignment elements and make those relative to the temporary alignment. Then I'm going to take the temporary alignment and offset it by the distance between the 2 parts. So in this case, 10 inches. So you can see I have moved the temporary alignment by 10 inches. Yes. Now when I go back to these alignment features, you can see that they have been properly moved to the new CAD feature, and then I can just set them back to, in this case, base alignment, and base alignment. Now the rest of the features are already relative to a sub-alignment, okay? But they're relative to sub-alignment 1, not sub-alignment 2. So here, I'm going to go ahead and make them relative to alignment 2. Notice I'm hitting keep position, so the nominals don't change. I'm going to go OK, and then I'm going to just format paint the alignment onto the rest of these. Looks good. Notice I'm just updating the features in alignment 2. So now it exists in its new location. We have alignment 1 here, alignment 2 there. All the features from alignment group 2 are over there. And here's the rest of the features. Now I said we'd have a problem with the pattern. Not a problem. That's hard to fix, at least. We can go here. I need to create a new pattern. It's another polar pattern offset. This one is now relative to alignment 2 and 60 and 6. And you see everything is where it properly belongs in those holes. OK and OK. So I can, of course, continue to repeat this process and create all the characteristics and features I need. So now I can get rid of this temporary alignment. I'll take all of these. Again, I can just form a group or not. I can also just go copy, paste, or if I want to have them come out as individual parts, I will do it like that, and simply take the entire thing, form a group, F2, part, group 1, copy, paste, and over here we're going to see that we're now into group number 2, point P2, and we just have to update all of these to use the number 2. Right there's another number 2, and another number 2. Notice that the alignment automatically updated for us, and the last number 2. So there we are. We've fully updated all of those characteristics. Now you may notice that it's still highlighting the wrong CAD model, as it were. Let's see, why isn't that where it belongs? That is this one. It is where it belongs. And it is actually where it belongs. There we go. Okay. So anyways, what we can do is simply do a CAD model comparison. So CAD model comparison. We'll run that comparison. And it looks like, oh, these are off, those are the two planes on the end, or the point on the end. So it looks like we actually need to increase our comparison number to 20. So let's do that comparison again. Found everything, so we'll highlight there, through there, and hit apply, and close. And so now everything should be pretty good if it worked out right. Ah, there it is. And there's the other group. Okay, of course, again, I just have done 2 of the parts in this pattern and only a few dimensions with each, but now we could run this pretty easily. So we'll take this 0.8 millimeter group, drop it down here. Nope, not inside of that group, but down there. So now we have 0.8 millimeter star features, and here we have 2 millimeter star features. Let's turn on our simulation. So Planner, Stylus System Simulation. I'm just going to use the probe and probe head so that it looks easy. Run. Don't need to do the manual alignment. And let's go ahead and hit go. So of course it's just going to run through this program. You see it's finished with the 2 millimeter probe on the first part. Now it's setting up the second part. That's it doing a probe change. Well, that was fun. I see that it's running in the wrong order, and I'm sure that that is because I dragged these into the wrong order. So we'll come here and do that. Let's look at that printout again. So now we have dim 1s, P1, and here's the beginning of P2. We, of course, can do some interesting stuff with that as well. So I just come to my characteristics. We've got part 1, part 2, and then we go here, resources, characteristic settings editor, and printout, group in custom printout, okay, and nope, it was not what I thought we would get, bummer. Resources, let's go back, characteristic settings editor. Of course, actually turning it on would help. And so now we see our group names in our printout automatically. And again, we can easily go through to part 1, part 2, part 3, part 4, part 5, etc. So pretty straightforward way to do this. It'd be fairly efficient. Of course, this becomes a thing where you say, well, gosh, how would I, run just one part, for example? Well, pretty simple, actually. You just kind of come over here, highlight the characteristics for whichever part you want to run. CNC start, current selection. That was a probe change, then it measures the fixture, and then you see it measuring only the one part that we are concerned with. And of course it will still do the probe change, which we'll see in just a second. There it is. And finishes off the rest of the measurements. There we go. And that's going to be it for today. Thank you very much for tuning in. I will not be tuning in and doing a stream next Friday as I'm going to be off-site helping out some customers. But hopefully the following Friday I should be able to find some time. So let's see. We are looking at probably Friday, June 2nd as the next stream that I'm going to run. Again, thank you very much for joining me on the stream today, and you guys have a great and wonderful